Hello, everyone. Welcome to San Francisco. Welcome to Summit 2018. Welcome to this session on hyperconverged infrastructure. My name is Sean Murphy. I'm a product manager with Red Hat, and I'm joined on stage by my colleague Doron Fediuk, who is a development manager, senior manager with RHI Engineering. Here's what I'd like to take a look at this afternoon. We'll start off by doing a little bit of we'll look at some customer dynamics that we've learned over the year or so that we've been to market with the Red Hat Hyperconverged product. That will lead us into a high-level product overview, and then we'll step to a kind of a near-term, longer-term roadmap view, the directions of the product in general. Following that, we'd like to do a focused review on a very compelling new capability that's going to be introduced in the product around data reduction, and we'll bring up Louis Immerschein to cover that section. And at the end, we're going to bring up a valued partner, Commvault, to look at some very cool solution that they released late last year based on that's built on top of the RHI platform with their system on top of that. But first, I don't know if you guys have seen these. This is a raffle ticket that I think will be handed out as we exit the room tonight. I don't have all the details behind it, but there are some terrific prizes. There's a couple of drones. There's some wonderful things, right? Be sure to get these on the way out. I think it's worth your while. And secondly, we've got, at the end of the session, when we do Q&A for any good questions, we've got this very cool USB fan for all you propeller heads out there. It's pretty cool. All right. You know, how do you guys make money on free software, right? People would ask incredulously for years. Not so much anymore because, you know, I think people, particularly in this room, at this conference, get that this isn't really about, Red Hat's not really about selling free software, right? There's a reason why 90+% of Fortune 500 companies have placed their bets running their operations around the Red Hat stack. And, you know, all of this works not by accident, but by adhering to some really core tenets. And those tenets are completeness of vision, right? We're not a one-trick pony. We don't have one particular product over here and another one over there, or just, you know, a single product. We have a suite, a portfolio of integrated products, right? Completeness of vision. Our ability to execute, solid business performance, right? We're a real company. We're going to be here for a long, long time, right? And lastly, trust, which, you know, you hear in our outbound materials, in our promotions, our advertising, things like that. Trust, right? You know, at first that might seem kind of trite in a way, right? But it's in all seriousness, it's a core value of the company that underpins everything that we do, and arguably that's more important today than ever. Those of you who were at the keynotes this morning saw, I mean, we always in the keynotes talk about open source software, right? Paul talked about it a bit earlier. He didn't use this term, but open source software has in large measure sort of crossed the chasm, right? An example of this is, I've been with Red Hat about 3 years now, and this is my 4th summit. Were any of you in Boston last year, the summit in Boston? Then you saw, right, there was we've spent all this time sort of pushing this message of open source, the value of open source software, and the phenomenon that we saw last year, particularly showcased at the summit in keynotes and in breakout sessions, was customers telling us about the great things they've been doing with open source software, right? And in many respects, you know, having also initiatives or directives or even mandates in some cases to be looking at open source software solutions for their 3 to 5 year planning, right? So that's been a big deal. That's a big change, and the energy around the open source community and the innovation. And I include in the broader community sense, I include in that not just the upstream folks, but also, you know, partners and you and customers, right? And I'll note that RHI today is the only fully open source software commercial offering for hyperconverged. Now you've heard me use the term RHI a couple of times, right? It's shorthand for Red Hat Hyperconverged Infrastructure, which is a kind of a mouthful. So you'll hear me use both terms interchangeably here. And then just a quick note on partners, right? Red Hat brings to the table not just the open source prowess and the other things that I mentioned, but also brings a diverse partner ecosystem to the equation, right? Which not every vendor can do. And when you're looking through the full solutions lens, the value of the network effect of having a rich partner ecosystem when you're trying to build out real solutions going forward cannot be overstated. So here's a quote from our CEO, Jim Whitehurst, that I think sums things up quite nicely, right? Sort of pulling it all together, making it consumable, making open source software the default choice. Now, we're heading in that direction, right, per my comments earlier about what we witnessed at last year's summit, and we know intrinsically here, every day. Becoming the default choice. Making it consumable is something that Red Hat has done all along to one degree or another, right? And today, it's even more important to make software solutions, integrated solutions, consumable, right? And Red Hat Hyperconverged Infrastructure is a great example of doing that. So I mentioned, we've been to market now for about just under a year, about 10 months or so with Red Hat Hyperconverged Infrastructure, and we've learned a couple of things. We've observed things with the customers that we're dealing with, and some of them are quite interesting, right? I think this room probably recognizes that HCI is effectively a logical outgrowth of converged systems and VM virtual machine aware storage, right? That is what formed the initial product category in the market, right? And that's what most people think of when they think of hyperconverged. But what we learned talking to various of our customers is that many customers are, in particular verticals especially, are just sort of now coming to the realization of HCI, right? They haven't been drinking the HCI Kool-Aid for the past 6, 7, 8, 9 years. So they're just seeing opportunities now in their organization where hyperconverged solutions, basically the infrastructure consolidation and the operational efficiencies that result from that consolidation, they're seeing opportunities around their orgs, around their operations, where this can actually work. So they don't really think of it, those folks aren't really thinking of it so much in terms of it being a product category, right? They're looking at what are the solutions that you can give me today, and do you have a long-term roadmap and a kind of a future in software-defined everything sort of more broadly, right? So what this means in summary really is that the basis of competition is starting to change in the space, and we'll talk a little bit more about that in a bit, but the decision criteria that people are looking at that we're talking to is not so much, oh, I've got this robo over here, or this line of business over here, or this departmental need, I better go out and buy a point solution to go fix that, right? They're looking at the bigger picture, the bigger lens, right? And that's where we're starting to get a lot of play here, right? And it's important to note that for us, we have obviously a very rich portfolio overall. We also have a very rich portfolio of software-defined storage assets, and we will hyperconverge those assets into the broader portfolio in ways that are, in any ways that are valued by customers. So Red Hat Hyperconverged Infrastructure sort of started by, like a lot of things, kind of a grassroots, right? We have had, Red Hat Virtualization and Red Hat Gluster Storage have had a relationship for a long time, right? With Gluster as a storage domain for years, right? What some of our more ambitious customers were doing was sort of taking both of these things and taking out the rubber mallet and kind of beating them together, to try to get them to work together in a kind of a hyperconverged model to varying degrees of success. But that's not a solution, right? That's a project, and it's not really a production quality kind of project. So we set to work based on the demand we were seeing and observing people doing this themselves. We set to work to build out a real solution, right? What they were doing was, 1 + 1 = maybe 2 at best case, right? Depending on how forcefully they hit it with the mallet. But in our case, we're saying, the whole is greater than the sum of its parts, right? This is the kind of the nature of this solution, and we built out a real solution with real integrated workflows and so on and so forth to satisfy that need. So we're standing on the shoulders of giants here, right? Because we've got two industry-proven stacks that are rock solid and highly capable, and then we put some additional work around that to optimize it even further. So just a quick look, sort of at a glance look at what the architecture looks like. Its simplicity and elegance kind of characterize the system overall, right? There are some really nice systems out there. There are some very complex systems, right, where there's a lot of complexity built into the system that doesn't necessarily deliver the goods at the end of the day in terms of wall clock time or however you're looking at performance, for example. This solution has the simplicity and the elegance is not just in the way that, from the operator point of view, but it's important to recognize that when we're talking about Gluster and we're talking about KVM, we're talking about very simple, tight, efficient systems, right? KVM is built directly into the operating system kernel. It's part of the OS. In the case of Gluster, you've got elastic hash algorithm instead of having to have have a separate metadata server that could introduce its own problems, right? Really simple and tight and elegant. And when we look at the data reduction stuff later on, same deal, right? Built directly into the into the kernel and the I/O subsystem in the operating system. We also built a bunch of optimizations into the system, including multi-threaded self-heal, disk sharding, and things like that for more efficient I/O, SSD-based caching, and so on. We'll talk a little bit. Doron's going to dive in a little bit deeper on some of the technical features. Again, we launched less than a year ago, and what we found was there was really solid reception from the tech press and analysts when we went out. This is just two examples of where we got some good news kind of press. I think they really got it. At least most of them did. This particular comment that from Terry McClure here references laying the groundwork for software-defined future directions, right? And I'll talk more about that in a minute, but that's actually becoming an important one. Use cases. When we initially started seeing demand for this kind of solution, a lot of it was centered around robo or remote office, branch office kind of use cases. And so that was where we pointed our arrows in that direction, right? So that was where when we initially delivered product, we were really looking at that as a target market. What we have seen since then, in the time we've been delivering product, is use cases and workloads are sort of across the board, right? Particularly, we're seeing activity in the energy sector, in oil and gas, and public sector. And manufacturing. That's where we're seeing a lot of the play. And I think part of that has to do with the comment I made earlier about some of these industries have not been, they're not entrenched in HCI. So they haven't been buying it and building it out for the past 8 or 9 years. And they don't, in a lot of cases, necessarily need the gold plating and so forth that comes with a lot of the solutions that are out there. To the comment I made a minute ago that was referenced by the analyst on the slide. Another area where we're seeing interest, right? You guys know where software-defined storage, broadly speaking, is on the adoption curve is still kind of making its way up, not for us, but for broadly for the industry. What we're finding is a lot of IT professionals are looking at the RHI solution as a way to introduce software-defined storage into their organization in a low-risk way, where they can kind of get their feet wet. Check the box. They have plans. They have goals in the organization. They want to deliver. They want to bring software-defined storage in. The IT director wants to get his quarterly bonus. Boom, he does it, brings it in. The idea is they will have a delightful experience with the product. It'll lower some of the barriers around software-defined storage. Any resistance around software-defined storage more broadly. That might seem a little bit fanciful, but that's what we projected, and that's what we've been seeing happening. And it was we had another analyst from a different firm confirm that recently, that they're seeing that elsewhere too. So I think we're going to start seeing a lot of play in that regard. And more broadly, watch this space, right? This is where we're going to be. Another key thing that unlocks software-defined storage adoption broadly is really automation, right? And you'll learn a lot about Ansible this week. We have a lot of Ansible plans rolled into the roadmap that are going to be very beneficial. Okay, in terms of other emerging use cases, there are a ton of them, right? But we can't show them all here. One of them that I wanted to reference is this one in particular, but before I do, I'll mention that one of the things you might see or hear about this week is this idea of running these small RHI clusters sort of as Red Hat OpenStack platform as an undercloud or as a control plane in its own sort of availability zone. We're finding we have at least one vendor, hardware vendor partner that's doing that already. And we have a number of customers starting to do those things. And so we have other solutions across the portfolio, too, that we can talk about offline. But I wanted to call this one out to your attention, particularly around IoT. As Red Hat starts to increase its IoT play, RHI is factoring in quite nicely. This is kind of a simple example. This is really a SCADA or a data acquisition kind of example. We've got a manufacturing operation or a plant that has a bunch of sensors running around gathering data all day, shunting it off to the RHI on the edge of the network with some analytics software running on top. This is another place where our partner network comes in very handy for delivering full trusted solutions. Well, you'll hear more about this, I think, elsewhere at Summit this week. And right now, I would like to hand off to have Daron jump in and give us a little peek under the hood at a couple of compelling capabilities. Daron?
Thank you, Sean. Yeah. So, hi, everyone. I'd like to go a little bit deeper and look into the technical aspects. We've heard that 1 + 1 is greater than 2, and let's take some concrete examples coming up in the next Rev version and incorporated into the next RHI version. So, first one is related to hosted engine. We dramatically simplified the whole deployment parts of hosted engine. We have a cockpit-based UI, and of course, under the hood, we have Ansible automation. You can leverage that for your own automation, but the whole automation part, the whole deployment part became very, very simple now. What that means is that once you get it up and running, you already have some of the internal complexities that we used to have removed. And in that way, you have a very robust solution for your management part. Beyond that, we can look into the high availability aspects of the virtual machines, your own workloads. These have been improved as well. In the past, for example, when we had a storage-related hiccup, for example, VMs would pause by default. Now you can select a policy, whether you would like to keep them paused, automatically resume them, or maybe kill them, because we did get requests from customers that would like to automatically kill the VMs as well. So you have a policy now, and this as well will be a part of the next RHI. And of course, looking at the cluster area, we have self-healing, which is being improved. They introduced the arbitrary in the past, and they are working on improvement of that. But again, taking a step back and looking at the bigger picture, we have high availability aspects in all the layers, and then we have data integrity achieved by cluster self-healing mechanism that, as a whole product, gives you a very robust and strong solution. And the question is if we can do better than that. Better than that means let's lose the whole site. What's going to happen to us? DR, disaster recovery. So, in the past, the old Rev days, which means before Rev 3.4, we used to enable customers to do backups of their virtual machines. Moving on, in 3.4 and 3.5, we introduced a way to capture the metadata of the virtual machines, do a nice mapping, and try to recover lost or corrupted storage domains. In 4.2, which is the nice announcement we heard today, we're going to have fully automated DR solution, which is based on Ansible. Let's see how that works. Okay, this is a three-phased process, basically. We begin when everything is nice and quiet. We have a production site, a main site, and we have a secondary site. Everything is working nicely for us. We used Ansible to generate a mapping file that allows us to map the resources in the production site, networks, and storage to all the objects and entities inside the system. We can copy that into the secondary site to ensure that it has a very similar mapping. Even if the names there are different, we get an Ansible-generated template, and we can update it manually if we have specific things like credentials that we would like to do a little bit differently. But again, this is the easy part where everything is nice and smooth. Let's assume that disaster strike and we lost the site. Okay? The first thing that we would like to do is quickly go and update any changes that we had in the mapping file. Usually it shouldn't take long. And we just use Ansible in an automated way to fail over to our backup site. Okay? There's nothing the user needs to do there. You will see shortly, I have a nice demo of it. Ansible is doing everything for you, and that's great. Basically what Ansible will do is attach the storage domains to the secondary site, register the VMs, do any updates that are still needed, and you will have your VMs up and running with as little downtime as possible. And this is a big change to anything we had before. In the RHI scenario, we also have geo-replication of Gluster, which helps us as well. Okay? Once we got everything up and running and we saved the world, we continue to the next step, which basically means fixing our production website and failing back to the main site. This is also done by Ansible. We have a nice playbook for it. There's a very simple script that runs that. It will detach the storage domain from the secondary site, attach them to the main site, and you will have your main site up and running in no time. Let's see how it looks like. I have a demo here. This is basically starts from the point in time where disasters strike, and we need to do something about it. Let me just adjust the video here so we can see it properly. Yeah, this should be fine. Okay, what you can see here on the, whoops, it's running too fast. On the upper side, we have our main site. You see that it's currently running. And on the lower side of the picture, you have our backup site, and it's currently down. I'm going to play the video a little bit. And basically, disaster strike. We're going over the mapping file, which was automatically generated by Ansible. And for the purposes of the demo, we just changed one of the roles in the system to show you that the backup will get something different than what we used to have. And now you can see that all we're doing is running a simple failover script, which is being powered by Ansible. Let's see how that looks like. What's going to happen is that Ansible is going to attach the storage domains, and this is what it's trying to do right now, to the secondary site. And this is the main site. You can see that it's currently down, and the secondary site is trying or starting to activate. You can see storage domain being activated right now. Once all the storage domains are active, we will see VMs being registered and restored automatically. So if you had a VM running before, you will have it running again. Okay? Takes a few seconds in the demo, probably a few minutes in reality. But here, you can see that the user is now refreshing to see that the VMs are actually starting automatically. He's not doing anything else. Okay? It's a full DR solution. And now you can even see that the role was changed compared to what we used to have. Here. This is it. So, let me just stop this. So we saw that we can do a lot with Ansible, and we're quite grateful for Ansible to help us with DR. This is indeed quite advanced to anything we had before. And the question is if we can do more with Ansible, and this is a trivial question because the answer is definitely yes. As I mentioned earlier, we completely rewrote the whole deployment parts of Hosted Engine. We have a very nice user interface now and a cockpit-based deployment and wizards. I want to show you that as well. This applies, of course, to RHI as well, because the whole RHI deployment relies on it as well. So let's just fix the quality here. Okay. Now you can see how simple and user-friendly the new deployment is. We removed a lot of the complicated logistics and questions that the user had to add in the past. We just kept the vital things, or the mandatory parameters that we really need to have. We used as many defaults as possible, same defaults. And as you can see, there's even online validation as much as we can. So if something goes wrong, the user gets an immediate feedback on screen. The first step is basically creating a temporary VM, which will become the future hosted engine virtual machine. Once we get that sorted out, we will move on and we will add all the parameters of the engine. That should be very, very fast. And once we do that, we will actually build the VM. We get a review screen to make sure that everything we wanted is actually there. And now you can see Ansible doing, again, all the work for us. It's updating, it's creating everything. And once we have a VM running, okay, we will move on and configure the storage. Since this is a RHI scenario, we already have our bricks and volumes ready for us. So all we need to do is ask that to run using the cluster configuration, and we're basically done. That's it. Very simple, less user mistakes, more automation. This is very, very important. Sean?
Yeah, very cool. Thanks, Doron. So a quick look at where we're going with the product. This is obviously not a detailed roadmap. I would invite anyone that wants to take a little bit of a deeper look at that to come see me, down on the floor or at the booth or whatever, right? But for the purposes of this discussion, I wanted to give kind of the high-level view. Right, we talked about kind of the release cycle to now. What we're calling here as RHI.next is targeted for real soon now. It's in the summer bracket. It'll be pretty darn soon. The pillar features or capabilities of the product are, I've mentioned a couple of times, we've mentioned data reduction. Lewis is going to come up here and tell us exactly what that's all about. Doron talked about the DR site-to-site enhancements that are coming. And in just a moment, Doron will take a look at the addition of vGPU support that's coming with this next release, as well as single node deployments, which we've been seeing a fair bit of increased demand for single node RHI system that can be expanded later. So, Doron?
Thanks, Sean. So, as Sean indeed said, we are improving as much as we can. Most of the following features are basically based on customer request. We got a lot of requests on supporting a single node mode, which is basically an appliance you put in a gas station or you put in a medic clinic. The staff there has no IT experience. They don't need to deal with that. If something goes wrong, you just take it back to IT, get a new one instead, replacement, and that's it. So we're extending RHI to support that use case. It's a very important appliance mode use case, and that's going to be supported. It's already implemented in Rev, and it's going to be a part of the next RHI version. The next option or the next use case is utilizing existing local storage in existing deployments. We have customers who have a multi-hypervisor strategy. Can we save questions for the end, please? Thank you. So customers implementing a multi-hypervisor strategy, and they would like to use and leverage the local storage in their existing hypervisor, and for that we're extending RHI as well. And the last, as indicated by Sean, vGPU support. There is NVIDIA support. It requires NVIDIA drivers for the guest and the host, and there is Intel work or Intel support in the works, still being developed. but this is already coming in Rev 4.2 for NVIDIA. You can join us later and get more answers if you have any questions on that specific feature. But it's very exciting. There are many, many interesting use cases, including AI and artificial intelligence and machine learning, which are going to benefit from that. And this is, as I said, coming in the next RHI version. One more thing I'd like to do is maybe look at the longer-term future. As we heard this morning in Paul Coumier's keynote session, containers and open hybrid cloud, these are also very, very important. It's a vision of Red Hat. We're not talking about tomorrow. We're not talking about the next RHI version. This is 5 years from now, but it is in our thoughts and in our roadmap. So let's just understand what it actually means, okay? Application containers are coupled with Kubernetes today for management, and there's an increased demand to do more and more support for containers. There are various reasons for it, whether it's cost for reducing the cost, for various workloads, but on the other hand, we also have virtualization, which is still there. It's not going anywhere. It's going to stay with us for many years. So people are trying to figure out how can we combine container world with virtualization world. This is a very challenging a very challenging problem we need to deal with, and we're looking into the whole hybrid cloud as something that we should probably answer in the future, okay? And the solution to that is container native virtualization, okay? It's a great opportunity for Red Hat to show its 10 years of virtualization experience and all the knowledge that has been gathered on containerization and management with Kubernetes, and allow OpenShift to manage virtual machine alongside with containers. So this is really, really exciting, but as I said, it's a longer-term vision we will be looking at. Now, back to you, Sean.
Yeah, thanks, Doron. And that speaks to, were people at the keynote this morning and heard about this container native virtualization? And there are some sessions around here as well. I encourage you to attend them. It's important in showing the future direction of products like Rev or RHI, right? This is not just in the case of RHI, it's not here's a hyperconverged infrastructure thing today, and then 3 years down the road get rid of it, right? This has a future. We have direction here. We have long-term vision around the company in general that helps drive the prospects of this. So as I mentioned, Louis Immerschein is going to come up here and educate us all a little bit on the data reduction benefits that are being introduced in the RHI product in a soon-to-come version of the software. Louis.
Thanks, Sean. So I'm Louis Immerschein. I'm the principal product manager responsible for data reduction at Red Hat. Mr. Dedupe at Red Hat, essentially. I came here as part of the Permabit Technology Corporation acquisition, which was a little over, I think,
August.
7-8 months ago, yeah. And the product that we introduced, that we used to sell called VDO, or Virtual Data Optimizer, is now part of Red Hat Enterprise Linux, beginning with RHEL 7.5. And that's a 6-year-old mature technology, which is why it's not a tech preview. It's a fully supported component of Red Hat Enterprise Linux at this point. Let me start by kind of describing the problem that VDO was designed to solve. Great, faster storage is better, right? The first VM that somebody launched was wonderful. When they launched, the problems came when they launched the second VM, right? So increased performance enables greater VM density by speeding up boot times and reducing I/O contention. But that performance, of course, comes with higher costs and reduced capacities. So we introduced VDO data reduction to reduce the cost of high-performance storage. And it's not the deduplication that you're used to from the backup side, it's the dedupe that you're used to in primary storage. and now that deduplication is embedded in the OS. The RHI engineering team is integrating this kernel module, the VDO kernel module, into cluster storage bricks, and that'll allow those cluster storage bricks to deliver inline, on-the-fly, 4 kilobyte fixed deduplication, data compression that's optimized for high-speed random access, as well as a thin provisioning feature that has zero-block elimination. The benefits of all of this, well, it increases the affordability of high-performance storage. It extends the life of flash-based storage devices, and it allows you to repurpose storage hardware you might already have. So how's all of this work? Well, I mentioned this is a RHEL kernel module. So when data is written, when a stream of data is written to a VDO storage device, all of the zero blocks, all the blocks that are zero filled, are first eliminated. Then we'll check against our index, which is a separate driver called the UDS driver that you'll learn about if you look at the VDO documentation. And we verify whether those blocks have been seen before or not. If not, we don't have to write the blocks. We only have to update a little bit of metadata. And then finally, we compress the remaining blocks and pack them together into 4K blocks. And I should mention that RHI is going even further than this because they're integrating that VDO data reduction with their administration workflow, which turns out to be something that's not trivial to do. And depending on how you're planning to use VDO in your environment, you may have to do that yourself. So it's nice that they're taking care of that. So how is VDO data reduction unique? How is it different from other primary storage data reduction technologies? Well, one thing that isn't on here is, of course, that it's software defined and it's in the operating system, which means that anywhere the operating system lives, whether it's in the cloud or on premise, wherever it is in RHI, VDO will operate, and it's not tied to some proprietary hardware, and that's almost the definition of software-defined storage. So a key point here is that deduplication by VDO is done inline and on the fly, so there's no guessing about storage consumption or no bursts of performance impact from optimization done in the background. Also, VDO operates efficiently with 4K chunks, so very small chunks. And this is important because if you've got deduplication operating with 128K chunks and you change 4K, you've got to write a whole new 128K chunk. With VDO, you've only got to write 124K. That's a little quick math there. But that's 97% data savings right there on that block. And we're able to keep track of those 4 kilobyte blocks in extremely low memory. In fact, it's less than 0.03% of relative to RAM to disk. And this is super scalable. We're able to scale today to 256 terabytes of physical storage that's presented to us, so that's after RAID protection. And we can present that as up to 500 terabytes of storage for each brick. Now, actually, VDO supports larger, but we have the limitations of XFS, and we can operate with those. So the other point about VDO is it performs well with random I/O workloads. And it can do this because blocks only get compressed the first time they're seen. So our deduplication process is extremely fast. And so after we've compressed the block the very first time we see it, we don't ever have to do it again because we already know about that block, and it's already stored. We're also able to read in chunks of data without having to do bigger I/Os or large compression operations. So we're packing together 4K chunks, and if I need to read back a 4K chunk, I just have to do that one 4K I/O to read it back. I don't have to, for example, if I were compressing large streams of data, writing those, and then needed to read back 4K, I would have to uncompress the entire large chunk. So this is really optimized for random I/O, and that's what I want you to take home. So how much can you actually save? There's a lot of, I will say, false advertising that's happened around data reduction over the years. And if you've used data reduction in the past, you've probably lived this. But really, it boils down to that there are two types of data. There's compressible data on one hand, and there's redundant workflow data on the other hand. Compressible data is usually textual data. It can be databases that have textual content. It can be messaging applications, monitoring, alerting, tracing, systems or application logging. And the most you can hope to get out of that kind of data is realistically 4-to-1 data reduction. And frankly, you're usually going to see less. The redundant workloads are where you see the most benefit. And in those cases, virtual desktops, virtual servers, containers, any concurrent operations going on where there's multiple people accessing the same files on the same storage, all of those are going to see high rates of data reduction, upwards to 6-to-1 or even more. And when all of that gets combined together, that's when you see these numbers that are coming from storage vendors, where they talk about, average 5-to-1 data reduction, for example. It's the merger of the two, because we don't just have redundant workflows, we also have compressible data, and we have some data that doesn't compress at all. And that takes us to the next slide, which is, when should you use this? So the first question you've got to ask is your data compressible? If it's not textual based, if you've got video or audio recordings, leave video off. If you have workloads that produce duplicate data, so I mentioned the case of the video files, right? I may have video players that are running on the same storage system, and the video players may all be running in VMs. So we've actually talked to customers who do want to use this in the video case, but they want to use this, again, for this redundant workload case. And then the last thing is, as you're factoring these two in, if you can say yes to one or the other, and faster storage is going to help you, you should consider using data reduction, because it may make a faster tier of storage more affordable. Now let that sink in for a second. You might take a 20% hit on that faster tier of storage, but that faster tier of storage might be an order of magnitude faster than the storage you had before. If we can deliver it to you for the same price, that's a pretty attractive thing. At this point, I'm going to let Doron.
Well, in the interest of time, I was a bit too chatty in the beginning there, so what I'd like to do at this point, thank you, Louis, is ask Meir to come up, and Meir's joined us from our valued partner, Commvault. As I mentioned earlier, they've got a really cool solution that they introduced to the market late last year, and they've built it on top of the RHI platform. So, Meir.
Right. Thanks, Sean, and hello, everyone. My name's Mayur Devaikar. I'm with Commvault Systems. So if you don't know who Commvault is, we are a data management company. So we do data protection, data archiving, e-discovery. We have been in the industry for over 20 years, and we are one of the leading providers of data management software. So what I want to talk about today is how we've built out a hyperconverged data management solution using the RHI platform. So if you look at the issues that people run into typically when they're doing data management, the issues are very typical, right? So you have an entire life cycle of solution implementation that you have to go through that starts right from acquiring a solution to putting it into production. Then you have to patch that solution. So there are a lot of different moving parts, and there are a lot of different vendors and complex interop that you have to worry about. And what this essentially comes down to is that there is a lot of complexity when it comes to managing your data management infrastructure. So this has been typically how people have dealt with data protection solutions. What happens also with the legacy data protection architectures is that when you're trying to architect a solution, you have to predict what that growth is going to look like in year 3, year 5, because most people are buying a solution, on day 1, but they have to think about what that infrastructure is going to look like in year 3 and year 5. So they have to predict the data up front. What often ends up happening is that data grows, right? So companies have a lot more workloads coming in. Sometimes there are M&As that happen, and so there is more data coming in. And that infrastructure, which was really built out for on day 1, is really not able to keep up. Very often people end up adding capacity, but just adding capacity is not enough, because you're not able to keep up with the compute needs of that infrastructure, and you very often end up in a situation where the performance degrades even though you have more capacity. So what typically also happens in year 3 or year 5 is that you have to go through a refresh cycle. And refresh, as we all know, are extremely painful when it comes to IT infrastructure. So you have to go through the process of buying your hardware all over again, and you have to move data from your existing infrastructure to your new infrastructure that you've just brought in. So that process, when it comes to data management, is a very disruptive operation for most of our customers, and that exposes the business to a lot of downtime risk because you have to take servers down, you have to migrate the data. So this is one event that most people don't look forward to in the world of IT. So what we did was we basically said, look, there's a need to really do things differently and really rethink how data management has been deployed in the industry, right? So we partnered up with Red Hat, and we built out a solution called Commvault Hyperscale. So what Commvault Hyperscale basically is, it's basically a hyper-converged data management solution that is using the Commvault data management, and we're using that in collaboration with Red Hat Hyperconverged Infrastructure. So Commvault software running on the Red Hat Hyperconverged Infrastructure, that's kind of the underlying infrastructure that we are running on this solution. So it's a highly distributed scale-out architecture. It is using all the benefits of the Commvault data platform. So it uses basically all the features that you have in the Commvault platform. So no compromise there. And our core value with the solution is simplicity. We want to really simplify how people are deploying data management solutions. And so we are really simplifying how people acquire and also deploy the Commvault Hyperscale solution with, with the combination of Commvault data management and Red Hat Hyperconverged Infrastructure. We are also able to linearly scale capacity and performance, and with all the features that the Red Hat team talked about here, we're also able to get the same resiliency into the Hyperscale platform because we're basically getting all of that inbuilt from the RHI platform because we're directly using that within the Hyperscale platform. So we have 3 different consumption models. What we have done is we have basically built out the solution in an appliance form factor. So if you want a complete turnkey solution, we have it available in an appliance form factor. We have also built out reference architectures with industry vendors such as Cisco, Dell, Huawei, Fujitsu. So pretty much all major server platforms we've got covered with reference architecture. So if you like any of these vendors and you have an existing relationship with them, you can deploy the Hyperscale software on these reference architectures. We also have a relationship with Cisco, through which Cisco can resell the Hyperscale software on their UCS servers. So if you buy from Cisco, that's an option to go with as well, because Cisco can resell the Hyperscale software on their UCS servers. So I'm going to touch very briefly on how we're using RHI in the Hyperscale architecture. So what we have basically is 3 nodes that we start out with. So these are basically 3 commodity servers. And in those commodity servers, we have a combination of flash. So we have NVMe and SSDs. And we use the NVMe and SSD layer to basically we use that layer for hosting our deduplication database, our index cache, and also to run the software itself. So the Commvault software, the operating system, which is Red Hat Enterprise Linux, all of that is running on the flash tier. And then the data that we actually protect using the Commvault software is actually being put on the SAS hard drives. So the SAS hard drives are basically being pooled into a storage pool. So all the nodes have access to that data because it's basically a shared storage pool that is being managed from within the Red Hat virtualization layer. What we also have is this thing called a CommServe, which is our catalog server. So the catalog server keeps track of all the data that's being protected by the Commvault software, and that CommServe is running within a VM, which is running on the Red Hat virtualization layer. So as you can see here, we're using pretty much all the benefits that the platform has to offer. So Red Hat virtualization for hosting our CommServe, and then we are using the RHI platform to basically create a hyper-converged storage pool for backing up the data. One really cool thing that we can also do with the with the CommServe, because it's running on the Red Hat virtualization platform, is that we can make it highly available. So if any node goes down in our setup, we can move, and if that node controlled our CommServe, which is our catalog server, we can very gracefully migrate the VM from that failed node to another node in the setup. So we're basically implementing a high availability as part of the Red Hat virtualization platform. So this is just a little bit more detail. So it's basically Gluster file system that runs on the storage pool, and we are using the hosted engine to basically manage the entire process underneath the layers. So the question always comes up, why did we use Red Hat? Why did we not write our own file system? Because there are a lot of vendors out there that are writing their own version of a scale-out file system. To be really honest, we wanted to go with a company that had a proven product already out in the market. So Gluster, as you all know, is not new. Red Hat virtualization is also not new. It's been out there for a long time. And so we needed a partner that we can go to market with that already has an established product that we can simply reuse in our product. So that's what led us to Red Hat and the RHI platform. And what we realized was that with the flexibility that we have in the RHI platform, the fact that it's open source, it is something that is very flexible. You can run that on any hardware platform of choice. That gave us a lot of benefits in terms of our ability to choose the hardware platform of choice. So we use servers from Fujitsu. So we use OEM servers from Fujitsu. That's what we have in our appliance form factor. And the RHI platform works just beautifully with that, no issues at all. And then we've been able to really align our roadmaps with the roadmap of Red Hat and also with the community, right? So we're getting all the benefits of the development that Red Hat's doing in the community. So we get all the benefits of all the features that go out in the community, and then the work that Red Hat also does on their own in their distribution, we get access to that as well. So we're really using all the benefits of Red Hat, the community, all the benefits we get from that. I think we're getting all of that here in the Red Hat RHI platform, and as a result in the Commvault Hyperscale solution. So that's all we had in terms of slides. So the product has been out in the market for 8 months now. Super successful. We're seeing a lot of adoption. And the integration we have done with the Red Hats worked beautifully. So kudos to you guys for getting a brilliant product out to market. So I think that's all we had in terms of slides.
Yeah,
right?
I know I think we're running a little bit late. I think we started a little bit late, and I was a bit verbose earlier on. Thanks, Mayor, very much. Okay, thank you very much.